Welcome to The Explainer. Today, we're talking about a huge idea, a breakthrough that might just fix one of AI's biggest, most fundamental flaws. We're talking about building an AI that can learn, a lot more like us. So, what if an AI could learn just like a human brain? I mean, really learn. We tend to think of these models as, super intelligent, right? But they've got this secret weakness. A huge one, actually. For all their power, they can't do something that we do every single day without even thinking about it. Learn continuously, for their entire life. And this really lays it all out. Our brains, they are just incredible at adapting. It's called neuroplasticity. Our brain physically rewires itself when we learn something new. It's amazing. But the AI models we have today, they're kind of brittle. They're mostly static. You teach them something new and poof, they can completely forget something they already knew. It's like this bizarre form of digital amnesia. So, this brings us right to the heart of the matter, AI's big memory problem. And trust me, it's a huge one that researchers have been wrestling with for a long, long time. And there's a name for it, catastrophic forgetting. And it is just as dramatic as it sounds. Think about it like this. You have a genius AI that you've just taught to be a grandmaster at chess. It's brilliant. Then you decide to teach it how to identify different types of birds. Well, guess what? After it learns about birds, it might completely forget how to play chess. Like it wouldn't even recognize the board. All that previous knowledge, just gone.
So why on earth does this happen? Well, for a long time, the way we've built AI has been kind of disconnected. We've treated two super important parts as totally separate things. You've got the architecture, that's the what, the blueprint of the model, and then you have the optimization, that's the how, the rules for how it learns. It's like building a car engine and then, as a complete afterthought, figuring out how the fuel is supposed to make it run. They were never really designed to work together seamlessly.
But what if that whole separation is the core of the problem? What if we've been thinking about it all wrong? That's where a new idea comes in, a whole new paradigm called nested learning. And the idea behind it is pretty mind-bending. The researchers basically argue that the model's architecture, the what it is, and the rules it uses to learn, the how it learns, aren't separate things at all. They're fundamentally the same concept, two sides of the exact same coin. It's not a blueprint and a user manual, it's all one integrated system. So what does that look like? Well, nested learning completely changes the picture. Instead of thinking of an AI as one big single brain trying to do everything, picture a system of smaller learning problems all nested inside each other. It's like those Russian nesting dolls, but instead of dolls, it's learning processes. Each one is connected and each one is learning. Okay, that sounds cool in theory, but how does nested learning actually work? Let's break it down. Okay, so because you have all these nested layers, you can do some really clever things. Each problem or layer has its own little stream of information. And here's the kicker. The system can tell different parts to update at different speeds. This is huge. It creates a multi-timescale learning system, which, by the way, is a lot like how our own brains work. Some memories are fleeting and some are locked in for a lifetime. And all of this leads to something truly groundbreaking. They call it a continuum memory system. It's not just an improvement, it's a total rethinking of AI memory from the ground up. So think of it like a spectrum. You have these really fast updates for short-term stuff, like what were we just talking about a second ago in this conversation? That's your short-term memory. Then you have medium updates for, say, adapting to new trends or information that's come out recently. And way at the other end, you've got these super slow updates for the deep core foundational knowledge, the stuff that should almost never change. Fast, medium, slow, all working together in harmony, just like us. All right, so the theory is fantastic, but does it actually work? I mean, for real? Well, the researchers put their money where their mouth was and built a model to prove it. And they named it Hope. Pretty fitting, right? Hope is a new kind of AI architecture that's self-modifying. Now, what does that mean? It means it can literally change and optimize itself as it learns. It's learning how to learn in a sense, all based on these nested learning ideas. So, how did Hope do? The results? Well, they speak for themselves. In language modeling, they use a score called perplexity to see how good a model is at predicting the next word. All you need to know is lower is better. And as you can see, Hope just blew the other models like the standard transformer out of the water. And it wasn't a one-trick pony either. They tested it on common sense reasoning. Here, a higher score is better. And again, look at that. Hope comes out on top. This shows it has a much more solid grasp of, well, how the world works.
But here, this is where it gets really, really impressive. They put it through a long context memory test. This is the classic needle in a haystack challenge, where you hide one tiny piece of information in a gigantic pile of text and ask the AI to find it. And look at that score. Hope absolutely nailed it. This is proof that its continuum memory system isn't just a fancy name. It really works. So, what's the bottom line? The researchers' conclusion is pretty clear. When you stop treating the architecture and the learning rules as separate problems and you unify them, you don't just get a slightly better AI, you get something that is fundamentally more expressive, more capable, and way more efficient. It's a whole new playbook. Okay, so what does this all mean? What's the big picture here? Why should you and I care about this? Well, nested learning is a massive step forward. It's about finally bridging that gap between the static AI we have now and an AI that can learn continuously, adapt, and pick up new skills over time without that catastrophic forgetting. We're talking about an AI that could actually grow from its experiences, just like us.
And that leaves us with a pretty wild thought to end on. If you have an AI that can genuinely learn from every single thing it does and it never, ever forgets, does it ever stop getting smarter? We could be right on the edge of creating a truly self-improving system, an AI that doesn't just know, it learns forever. And if that happens, well, that changes absolutely everything.